In this video, we'll be solving systems of equations by graphing. So let's do some examples. So given the equation x minus y is equal to 3 and x plus 2y is equal to 18, graph the equation and find the point of intersection. Now, if we can get these equations written in slope-intercept form, we can quickly graph the equation. Let's do that. So for the first equation, if we subtract x from both sides, we get negative y is equal to negative x plus 3. If we divide both sides by negative 1, we get y is equal to x minus 3. Now, since this is written in slope-intercept form, we can see that the slope of the line is 1, and the y-intercept is 0, negative 3. For the second equation, if we subtract both sides by negative x, we get 2y is equal to negative x plus 18. Dividing both sides by 2, we get y is equal to negative 1 over 2 times x plus 9. So we can see that the slope of this line is negative 1 over 2, and the y-intercept is 0, 9. Now with these values, we can graph the equation. So I'll plot the y-intercept 0, negative 3. Now since the slope is 1, that means that the vertical change is 1 and the horizontal change is also 1. We can put a point at that location and draw a line that crosses the 2 points. That's our line. Next, let's plot the y-intercept for the second equation. Now, since the slope is negative 1 over 2, we can go down by 1 and go across by 2. We can place a point there and draw a line that crosses both points. Now that we have both lines, we can see that the point of intersection happens at 8, 5. 8, 5 is the ordered pair we were looking for. Now let's look at the second system of equations. Let's write the equation 2x minus 3y is equal to 6 in slope-intercept form. So we can subtract both sides by negative 2x to get negative 3y is equal to negative 2x plus 6. Now if we divide both sides by negative 3, we get y is equal to 2 over 3 times x minus 2. We can see that the slope is 2 over 3 and the y-intercept is 0, negative 2. For the second equation, x equal to y is the same as 2y is equal to x. If we divide by 2 on both sides, we get y is equal to 1 over 2 times x plus 0. With this, we can see that the slope is 1 over 2 and the y-intercept is 0, 0. If we plot the y-intercept for the first equation and then move up by 2 and across by 3, we can place a point at that location and draw a line that crosses both points. If we plot the y-intercept for the second equation and then move up by 1 and across by 2, we can place a point there and draw a line that crosses both points. With the lines drawn, we can see that the point of intersection happens at 12, 6, which is the ordered pair we're looking for. Finally, we have the third system of equations. So for the first equation, we can subtract negative 2x on both sides to get y is equal to negative 2x plus 7. We can see from this equation that the slope is negative 2 and the y-intercept is 0, 7. On the second equation, we can divide both sides by 2 to get y is equal to negative 2x. So the slope is negative 2 and the y-intercept is 0, 0. Notice that the slope for the equations are the same, negative 2. Now, because the slope is the same, we know that the equations are in parallel, meaning there is no point of intersection.